Section 3.5, arithmetic sequence as linear functions. So we're going to take this to one more step. We saw direct variation, now we're going to talk about arithmetic sequence. Key concept, seen it? What we're looking at here is we're looking at sequence, we're looking at something that is in order. We are talking about consecutive odd, consecutive even, consecutive integers. We're talking about things that are in order. Are they increasing by the same amount? Are they decreasing by the same amount? Here we go again, another context with the same concept, different context. If you look at the examples here, hopefully it's very clear to you. When you look at the sequence 3, 5, 7, 9, 11, how much is that increasing by? By 2s. If you look at 33, 29, 25, 21, 17, what's happening is decreasing by 4. We're looking at something that's in order, so you're going to be increasing by a constant amount. Again, here's the concept of constant, or it's going to be decreasing by a constant amount. Okay, that's what we're looking at with the arithmetic sequence. Increase or decrease by a constant amount. Hopefully the concept of constant rings that bell again, the fact that we're looking at slope or constant rate of change, rises and runs. First couple examples, looking at them. Is this an arithmetic sequence? Yes or no? Well, look at the numbers and then make a decision on your own. What's happening if you go from negative 15 to negative 13, negative 13, negative 11, negative 11, negative 9? We are increasing by 4. Is this an arithmetic sequence? Yes, it is a constant. Okay, because the difference between terms is constant. Okay, another example, this is fractions. Number one thing with fractions, make sure you have a common denominator. It's easier to make the comparison. 7/8 to 5/8 to 1/8 to negative 5/8. Is this an arithmetic sequence? No. Negative 2/8, negative 4/8, negative 6/8. This is not constant. If it's not constant, it's doing something else, and we have to consider some other kind of sequencing. So here's your chance. You can pause if you want to, decide if this is or is not. This is not. We're going from 2 to 4, which is an increase of 2, 4 to 8, which is an increase of 4, and right there we're done. It's not constant. Another example, you can pause if you choose. As I look at this, I see the 1 and the 2 that's standing out completely from the rest of the problem. I would automatically make this a 3 over 3, and I'd automatically make this a 6 over 3. Get yourself the common denominator. It is easy to make the comparison. 2/3 to 3/3 is an increase of 1/3. 2/3 to 4/3, increase of 1/3. Again, we've seen the concept of common denominators. It's just coming true to another location for us. Okay. The next place we take arithmetic sequence is once we know if it is arithmetic, in this case, from negative 8 to negative 11, are we increasing by the same amount? From negative 11, negative 14, negative 14, negative 17, yes, we're decreasing this time by 3. Okay? We look for the common difference. Where are we going to go with this? This happens to say the next 3 terms. Well, I know if I'm decreasing by 3, decreasing by 3, decreasing by 3, I'm going to do it again. Where am I going to get to? Negative 20. Decrease by 3. Where am I going to get to? Negative 23. Decrease by 3. Where am I going to get? Negative 26. We're just looking the next 3 terms out. Just continue the sequence is what you've always done in the past. But what we need to consider is, what if I ask for 25th term? Do you really want to continue this out 25 times until you get to the 25th term? Or even worse, what if I need the 1003rd term? I really don't think you want to continuously make those arrows in the negative 3 and take your calculator and hit minus 3, minus 3, minus 3 over 1,000 times. And when looking at sequences in real life, that's kind of where we need to go with this, is where are we going to be at 15 years from now? Where are we going to be at 30 years from now? And that's what sequence is going to show us. So we get an equation. This is the official equation the chapter is presenting to us. Every one of those letters is telling you something. A1, right there. This is my very first term. And where I'm at in the sequence, this is my nth term. This is going to tell me if I'm at the first term The second term, the actual placement. D, that's my difference. It's called a common difference. We also know this as a constant or as a slope. We can put the other vocabulary there to, again, tie the different sections together. A sub n is wherever I want to be. In the last example, if I want the 25th term, that would be written as a sub 25. Now this is just one way we can do the arithmetic sequences with this particular piece. Or I'm going to show you an example of how we can actually set a table up. What I want to walk you through first, though, is how this equation works and what it looks like according to the book. This example, we're going 1, 10, 19, 28. How are we getting place by place? Find the common difference. Okay? We're going up by 9s. The very first term, that's the a sub 1, is at 1. Remember a sub n, a1, n minus 1 plus, n minus 1 d. The very starting term, that's the 1. N is going to be the variable. D in this case would be the negative 9, so I can kind of connect those together so we know that it's that piece there. And we can actually write an equation. First thing we do is find the common difference. Okay? If you're big on formulas, you put all the numbers in the right place at the right time. Starting was 1, common difference was 9, the rest of the variables stay in there, and you get an equation. Okay? Once you have the equation, okay, that's the equation we just had a second ago. Then we're finding the 12th term. We're finding the 12th term, so that 12 goes in place at the end. That's the term that I want. This is going to tell me the actual value. And in this case, it would be 100. So the 12th term is 100, if I continue the sequence out. What I want to do is I want to go back to that original page and I want to talk about an alternative way to solve this that I think you might find to be easier. If I simply set a table up, this is my x's, this is my y's, this is my input, this is my output. This is the term I'm on, this is the term, and this is its value. Again, the labeling is what we need to work on a little bit. My first term is a 1. My second term is a 10. My third term is a 19. My fourth term is a 28. Remember, we're eventually looking for the 12th term. That's what's coming up next. When I look at the table, what I'm looking for, same thing I would look for, is there a relationship happening here? So from 1 to 10, this is an increase of 9. 10 to 19, also 9, 19 to 28, also 9, and that pattern is going to continue. This is my rise. On the other side, 1 to 2, increase of 1, 2 to 3, increase of 1, 3 to 4, increase of 1. This is my rise. What's constantly happening? What's my slope? It is 9 over 1. Now the difference between this and the direct variation that is in section 3.4 is we need to consider, are we starting at 0, 0? Well, if I simply go backwards on my chart, which is easy enough to do with these numbers, if I go backwards one step, that puts me at 0. If I go backwards here, that puts me at negative 8. This is not the origin. That's my starting point. You've seen the equation y equals mx plus b, where m obviously is the slope, b is my starting value, or aka the y-intercept. This is where you again pull another concept back in from previous lessons. This is my y-intercept. I have everything I need sitting in a table form, so I can write this equation y equals slope, which is 9 over 1, plus my y-intercept, which is negative 8. Clean it up, y equals 9x minus 8. How do you find the 12th term? 12 is my input. 9 times 12 minus 8. 108 minus 8. There's that 100 in a different way. This seems to be the method most students like better, is to set a table up. You have to, this is the part that the book will never give to you, this part right here. That's what you have to come up with, are those values there. Here's the table. This is how you would graph it. You can see now whether we're crossing at the 0, 0 point. If you look at the table here, we are not. We would need to extend this table down. We can do that. We've seen that before for -5, -10. We have to go down 2 boxes over 1, go down 2 boxes over 1, and it's going to be sitting where we need it to. This is not sitting in the perfect 1, 1, 0. This is up at 1, 4. I'm sorry, 1, 1. That's sitting at 1, 1. So that's going to be over here above the -10. So you can see in the graph that we're hitting the y-intercept. Looking at the formula, what term are we on if our a sub n or our term value is 172? Which term is this? Where does the substitution go? The 172 goes with a sub n, y equals 9n minus 8. X there, we can put it here also. Again, understanding what's the input, what's the output, putting the numbers in the right place at the right time, and solving the equations. Quick real life example. We have a sequence, arithmetic sequence 12, 23, 24, 45. Sorry, 12, 23, 34, 45 represents the total number of ounces of bag weights after each paper is added. Okay, quick example, baseline example. We first need to find common difference, positive 11. We put it into the formula, whether we use this one or we go back a step and we set a table up. Maybe we can set the table going this way this time. This is the x, this is the y. 2, 3, 4, increasing by 11, increasing by 1s. You pick up that slope. You'll see that. There it is, there's that slope. If I go back, here's that slope. If I go back one step and I think about going backwards on my table, if I take one step back this way, that puts me at 0. One step back this way, decrease it by 11 because everything else is increasing. We're going this direction, so we have decrease. We're at 1. Okay, y-intercept would be the 1. Again, look at that equation, and we have that y-intercept of 1. Okay, you can graph it and look at it. This question also asks about domain. Can we have partial newspapers? No. That's why our domain this time is very limited. We can go back and talk about domain also. Again, if you want to pause and check your work to see if you can get the same answer, please pause now. In this case, we get answer B. Talking about domain here, you can read through that example. Again, check out Connect Ed. It's got more examples. It also has an assignment there as well.